So far, we've talked about how bucket brigade devices were used to create relatively long delays, but that was not the only thing they were capable of. When set up properly, bucket brigade devices could also produce short, constantly changing delay times. This makes these chipsets excellent tools for making chorus effects. If you've ever experimented with the delay time knob on a delay pedal, you may have noticed that you can make the delay time so short that the repeats aren't really distinct anymore. This happens with delay times between roughly 20 and 50 milliseconds. These short delays almost sound as if the part you're playing is being doubled by another guitarist. If we want to further enhance that doubling effect, we need to fluctuate the pitch of our delay repeats by modulating our delay time. We can do this manually if we want to. Try constantly increasing or decreasing the delay time as you play a note. You'll notice the pitch gets lower as you increase the delay time, and gets higher as you decrease the delay time. I'll use a sine wave to explain what's going on here. The amount of time between two peaks of a sine wave is equal to the period of the wave, inversely proportional to the frequency, or pitch. If the sine wave is undelayed, or if it is delayed by a fixed amount of time, the period remains unchanged because the amount of time between the peaks of the wave remains the same. However, if we increase the delay as a function of time, something interesting happens. The first peak of the sine wave will occur at the same time it normally does, plus whatever the delay happens to be at that time. The next peak will occur where it normally does, plus an even larger delay, since more time has passed and delay increases with time. The amount of time between the two peaks is now increased. This means the period has increased, and since period is inversely proportional to frequency, the frequency decreases. On the other hand, decreasing delays cause the peaks to get closer together. The period decreases and frequency increases. When you modulate your delay time between 20 and 50 milliseconds, you get an effect that's called chorus, and by the mid-1970s, amp and pedal manufacturers were using bucket brigade devices to achieve this effect. Roland debuted their jazz chorus line of amps with the JC120 in 1975, being one of the first to offer chorus effects outside of the studio. In 1979, Boss released the CE2, a compact pedal based on the JC120's chorus circuit. To help demonstrate how bucket brigade devices can be used to achieve a chorusing effect, we'll be looking at a prototype circuit based on the CE2 schematic. The CE2 chorus uses a 1024 stage bucket brigade device, capable of delay times up to about 51 milliseconds. It also uses a LFO, or low frequency oscillator, to steadily increase and decrease the delay time. This LFO includes a Schmitt trigger, whose output can only be a positive or negative saturation voltage. These saturation voltages are roughly equal to the positive and negative supply voltages. The output of the Schmitt trigger is then fed into the input of an integrator. This circuit's output is the integral of the signal at its input. When the output of the integrator is fed back to the input of the Schmitt trigger, the whole circuit begins to oscillate. The Schmitt trigger outputs a square wave as it oscillates between its positive and negative saturation voltages. The integrator takes the integral of this square wave, making the output a triangle wave. This triangle wave is used to constantly vary the time it takes a timing capacitor to charge and discharge. Since the timing capacitor is connected to the oscillator pins of the bucket brigade device's clock generator, the clock frequency is regularly increasing and decreasing. This gives us the modulated delay time we need to make the chorus effect. We We can further tweak the sound by adjusting the LFO rate and depth knobs. The rate knob changes the frequency of the triangle wave, increasing or decreasing the speed of the pitch fluctuations. The depth knob changes the amplitude of the triangle wave, changing the range of delay times the circuit sweeps through and affecting the intensity of the pitch shifting. If you want to stretch the versatility of the circuit even further, we can get a vibrato effect with one simple modification. Chorus can be boiled down to a dry signal and a vibrato signal blended together. So all we have to do to get a vibrato effect is remove the connection that passes our dry signal to the output of the circuit. There's still so much about bucket brigade devices that I am leaving undiscussed, like how cascading multiple chipsets together can lead to longer delay times, or how delay times shorter than 20 milliseconds can lead to comb filtering and flanging. Nevertheless, I hope these videos have sparked your curiosity. I believe learning more about the technology that we use to make music can help us make better creative decisions down the line. If anything I've discussed in these videos has helped you understand or appreciate your gear even more, then I'll consider that a job well done. Thank you for watching.